Thank you for joining today. Today's topic is performance testing with a big data tool. The specific tool I use is Splunk, but you can use other big data tools. And the company I'm coming from is a company called Murex. The overview of today's topic is one quick slide on who am I, a little about Murex, just one slide to explain what my company does, the problems we had inside Murex, okay? So the issues we had. And then how we brought in Splunk to help us fix these issues, okay? And I'm gonna then do some real life use cases that we had about how this big data tool called Splunk helped us fix these use cases that went into production into these big banks in the world, okay? So who am I? My name is Robert Lynch. I'm a Splunk manager at the company called Murex. I'm also a non-functional test manager. So what does a non-functional test manager do? Well, we're all testers here, but let's just make sure we understand a functional issue versus a non-functional issue. So for example, if I get a developer to develop a GUI with two buttons, button A and button B, and the developer forgets button B, that's called a functional issue, okay? I can't press button B, it doesn't exist. A non-functional issue is that if button B exists, but I press it, and it takes maybe 20 seconds to come back, or maybe the CPU goes crazy, or maybe the whole platform collapses, and the server goes crazy and the network goes crazy. So usually non-functional issues are usually very technical, okay? And performance testing is a subset of non-functional. So non-functional is a big umbrella, and one component is performance testing. Now, so why do I talk about performance testing in the industry I'm in? So what industry am I in? I'm in the industry of banking, financial IT, okay? So Murex sells software to some of the biggest banks in the world, okay? And we have offices all over the world. Now, what's the one thing that will get financial IT removed from a big bank is bad performance. So let's have an example. What do we do? Well, I'm a trader in New York, and I'm trying to price a trade with a bank in Singapore, and I want to buy 100,000 Japanese yen. If the trader has an opportunity to buy this trade, and he presses book, and the system takes 3-4 minutes, the trader goes crazy. The bank has lost money, and they will go crazy. And then within 6 months, your system is gone, because these traders make millions. So if your software is slow, and I mean seconds, milliseconds, the traders go crazy, and then very, very quickly, people don't like Murex, and they're looking for the competition. So performance testing in the financial world is a big business. Also, let's take an example of a bank in London. They might have 500,000 live trades on their system. Every night, the markets have changed, okay? The dollar goes up, the ruble goes down, etc., etc. These trades need to be reevaluated every day. And what does that mean is that at night time, they crunch numbers. So they do lots and lots of mathematical calculations, and you might have a KPI, a key performance indicator. The bank has said to you, you have 1 hour, Murex, to crunch 500,000 trades, and we want a report. So this is a big deal, okay? So this is why we have a big office in Beirut with maybe 500 people, purely for testing, and lots of those people do performance testing, because performance in the financial world is a big deal, okay? Because if you are slow, you lose money. Simple, okay? So what is Splunk is the next question. Now, Splunk is a big data tool. 5 years ago, I was at a testing conference in Dublin. I'm from Dublin, Ireland. And a person was doing a big test. So what do I do in my job? In my job, when I do a non-functional test, say a bank is going to go live in 6 months. 3 months before they go live, My team gets the database, we get the binary, and we do a big simulation test, okay? So maybe we use 10 machines, and we simulate what's going to happen. So we get lots and lots of data. We get timing data, CPU data, network data, I/O data, garbage collection, data. So much data, terabytes of data. Human beings cannot read terabytes of data over, say, a 2-hour test. You need help. So in the old days, it was Notepad++, okay? Everyone open up Notepad, and you go through the logs, and everyone's going crazy, and it drives you mad. But these days, we have big tools. So you have like Datadog, you have Elasticsearch, you have Elk, you have Splunk. So big data tools like this are now big business because so much machine data is coming out, okay? And what do these tools do? They take the data in, and then you program it, and they create a visualization. So let's look at that. So in Murex, we've developed a system. So I developed a system. So 4 years ago, I introduced Splunk to Murex. And I made a system that any developer, tester, developer, consultant, who were doing any testing, could attach their environment to Splunk in 30 seconds. So they go, Splunk my environment. And all their data goes into Splunk. Also, our clients who are live all around the world, they're behind these big firewalls. So we cannot access this data. Bank security is massive. So they FTP us their logs, and again, we upload them to Splunk. And then we get visualizations, and then the system we created was that any Murex employee can access all this data from test, dev, operate, etc. I've made an open system, okay? So you have testers, you have developers, and all the data is going from the live environment into Splunk, and everyone is now seeing this data easily, quickly. It's a fully open system. So the idea is to no more Notepad++, and to make a system that's open. So I made the system for me at the start, and then I said, hey, this is good. So then I said, my team can use it. And then other teams said, hey, that's really good. Can you make it for us? So now my job is I go from team to team to team. I understand their problems. I understand their data. And I make visualizations like this. Because you had a situation where, I open up Excel. I import it. I open Excel. I run 20 macros. And I get the answer. And this takes 1 hour every day of this person's job. And this is crazy. You put it into Splunk, and it's done like that. All automatic. You have to train it, obviously. So you need to train. So the data comes in, you train Splunk, and you get the algorithms. This is a small success. Remember, I'm not Facebook, so I don't have 1 million users, but I have maybe 70 or 80 users around the world who are using the software that I've created, and we push it out. So this is a story that's in progress. It's not finished. So these are the users I have around the world, okay? And they're using the system, and they're uploading the data, and every day it's making their jobs easier, okay? So, but now let's talk about, what was the problem? So let's now zoom into one problem, okay? So I've made multiple dashboards from multiple data, but we don't have time to talk about it all. So I'm going to talk about one problem, okay? One problem was in the Java services we have, okay? This was produced in Dublin, and it's a limit service. And what it was we could time the class.method inside a JVM, okay? And we could produce a JSON file that gave an example. So let's have an example that a GUI takes 5 minutes to open up. And I go to the developer, hey, developer, like I'm testing, I'm a non-functional tester. That took 5 minutes to open the GUI. Like the bank will go crazy. That's not acceptable. You know what I mean? This has to be like this. So he goes, okay, so he looks at method.y. Now, normally in a code line, method.y has called a submethod, which calls a submethod, which calls a submethod, okay? This is normal. This is how coding works, okay? Now, this is a very simple example, but say it's 5 minutes, 2:05 to 2:10. And if we look here, we can see is that method.y was called once, but this also called another method, b, 6,000 times. But the problem is the 50 milliseconds. So the developer needs to reduce 50 milliseconds to 1 millisecond to get everything down quickly, okay? It's a very simple example, okay? The code line is much, much more complex. So why is this important? Because now we have the ability to add tracing in our Java at the product development, so shift left. So when say you're developing a new report, you put the tracing in. Then before you give it to a client, you do testing. And then when the client has it, UAT testing, it's all producing JSON data, which gives us an indication of what's happening inside the code line, okay? And then, of course, in production, because if there's a production crash in a bank, or if the trading is slow in a bank, they will send you the FTP, and they would expect you to work your weekend to find a solution, because banks pay a lot of money for this software, and they want solutions quickly. So what did we have? Historically, we had a PDF. Okay, now PDF is good. It's good for maybe 10,000 lines of this tracing. It was not so good for 100,000 lines, and it was very, very bad for 100 million lines, okay? Because you're graphing, like this big data is coming in, and you're saying, hey, PDF, I want you to graph this XY. Okay, I would take 5 hours to graph this. It's no good. So what did we do? I brought Splunk in. I trained Splunk, in this case, to read this trace, and we created a system. So I'm going to show 5 one-minute videos of just an example of the system that we created, and this is the system the testers and the developers use every day, okay? So they're short videos. So here we have the class, for example. This happened earlier for this video. So here we have the class, and here we have the method, okay? And then, for some reason, the video is refusing to play, so I'll keep doing press play. We have the method. How annoying is this? You know, I'm just going to quickly stop the PowerPoint and open it again. I'm sorry about this, guys. Just to see if this stops that problem. Okay, let's see if this works. Okay, I am showing nothing, so that is not good for you guys, but the video is playing. Ah, it's back. Okay, so there's the class, there's the method, and on the x-axis, we have time going across this way, and on the y-axis, we have measured time. So 10 milliseconds, 100 milliseconds, 1,000 milliseconds. Okay? And I'm just going to keep pressing play here. It does not want to play nice today. So 10 milliseconds, 100 milliseconds, 1,000 milliseconds. And now we can see each class.method, the exact time it takes, 600 milliseconds, 700 milliseconds, etc., etc. And also the developers can now see the full class.method and the average, so 800 milliseconds and 15,000 calls, standard deviation, the mean, the max, etc., etc. So why is this good? Well, because now it's a dynamic dashboard, and now they can zoom in if they wish. So you can see we can go to one section, and we can say zoom on selection, and we zoom in dynamically. So in a PDF, it wasn't dynamic, and now it's dynamic, okay? So now, again, if we do this, the mathematics below will update in real time. So now we're drawing, it could be 1 million lines of log, and we're drawing from it, and it's working in real time. Also, sometimes developers don't believe you that it's working. You can then produce the raw file here, okay? So you produce the mathematics, and you can also produce the raw file. So this is something that developers want to see. There's the raw file there as well. So we coined the phrase, if you graph it, they will see it. Now, why is this important? If you're doing a product development, okay? If you're doing product development and a developer is creating something new, sometimes they don't have a big database. They have a very small database. And they're trying to do non-functional testing, but they can't, okay? Because the database is so small, it's not really realistic. They're making a new code line, and often they pass it. They say, okay, it's good for performance, but they don't know. So if they have a 5-minute test, and if they graph it in this particular case, you can see obviously it started at 500 milliseconds, and it finished at 1,000 milliseconds. So there's an obvious trend going up for a 5-minute test. What's going to happen if a bank does that in 1 hour? It's going to be huge. So instead of the developer passing this, the developer will say, I can see there's a trend going here. There's something wrong here, okay? So let's have a look at the video there. So again, the trend is going up, 1,000 milliseconds, 2,000 milliseconds. We can see each class.method, but also each class.method is not trending upwards. Only some are. So now the developer gets an idea of, well, where is it broken, okay? So you give the information to them, and they get the average if they want, or they get all the mathematics. But it's about presenting the information to the developer so he can say there is a problem. Now, on a new point, you see this big peak? I'm a tester. I see a big peak. I'm not happy. Like, why is this here? I want to send this to a developer, and I want him or her to open this and to investigate. Now, if I can send a screenshot, or we developed a way to send an interactive URL that will bring them to exactly the point I'm at. So let's remember, there's hundreds of millions of lines of data, and I make a new test called soft test version 5. The reason it was trending because there was no index, by the way. But most importantly, I have now a unique hyperlink. I put that into email. I send it to developer, John or Jane, and I say, hey, can you look at this? They put it in the URL, and within 15 seconds, they are looking at the same problem I'm looking at, okay? It's not a screenshot. It's an interactive dashboard. So straight away, they're like, oh yeah, that's wrong, and they start looking at it. If you send a developer 20 instructions to get to your problem, they're not going to do it, okay? That's life. We live in the one-click world. If things are more than one click, people just don't do it. So when you're making any system, it has to be one click, you know? So what is a Splunk ID? An example here is time is on the x-axis. The y is CPU. A CPU is an easy one, everyone understands. And the Splunk ID goes out on the z-axis. So we developed this inside the tool. So this is client X, client Y, client Z, because we have hundreds of log drops from clients. We have thousands of live environments pushing data in. You have to be able to find your data very fast with the hyperlink. And this is what we've developed. So a Splunk ID creates a URL, and over all the terabytes of data, 15 seconds, you get your data. Okay? This goes down very well because now the testers make Splunk IDs, the developers make, everyone now makes Splunk IDs, and they send them to each other. So it's a form of communication over a test, okay, if you're in the agile world. Now let's talk about use cases. So I've introduced TPS tracing. So what is TPS tracing? This is Java class.method tracing, okay? How is this useful in a real life situation? So let's talk about one of the big problems we had. It was called the $1 trillion problem. It's a big title. And let me explain something in the banking world. So in 2008, there was a financial crash, okay? All the banks had a big problem. One of the things that came out of this was something called the liquidity crisis. Banks could not lend money to businesses because banks did not know if they had money to lend, okay? The governments came together and they said, we can never have this problem again. So they introduced something called the Central Clearinghouse Policy. So let's go back to the example. New York trader trading with Singapore. They're going direct to each other. This is normally called bilateral trading. The clearinghouse is in the middle. Now what happens is the trades go through the clearinghouse, okay? So why do they do this? Well, let's imagine now that the Singapore bank fails. The New York bank will get paid by the clearinghouse. So New York is happy. He's like, wow, this is great. It's like an insurance policy. The second reason is that the New York bank and the Singapore bank, normally when you trade directly, you have to keep certain money aside. If you use a clearinghouse, you keep less. So you can do more trading with the money you have. So banks can do more trading. That's the business they're in. Banks are happy. And the most important thing is the central clearinghouse has visibility of all the banks and how much money they have and they don't have, so that if there's a crisis, they will know how liquid the banks are. So the idea is we avoid having a liquidity crisis again. This is the plan. If it works, we don't know, because we haven't had the crisis again, okay? So what does this mean? It means that Central Clearinghouse is very popular. All the banks are now clearing, okay? They didn't 10 years ago, but now it's big business. So this, Murex have a customer, one of the biggest in the world, in Europe, and they were live and they were clearing. However, the regulatory authority were saying, you're clearing too slow. We need you to be super, super fast. And they said, how fast? And they said, we need you to do 60 position updates in 1 second, okay? So that's 17 milliseconds per trade. So 60 in 1 second. Through one line of code, which was a Java code, and sequentially, not in parallel, okay? So this was the challenge. And they said, Murex, you have 3 months to fix this problem. So they asked me to be test manager. So I got 2 testers, I got 2 developers, and I got 2 consultants. Consultants understand the financial world, okay? So there's 6 of us on the team, and we had 3 months to achieve this KPI, because the bank was saying, you need to do this, or maybe you're gone. So, and because it was such a big contract, there's a lot of pressure. So I talked to my friend John, and this is where the story gets a little funny/insane. And I said, John, do you know how much these guys clear? And he goes, no. I said, John, they clear $1 trillion. And he's like, they clear $1 trillion a year? I says, no, John, they clear $1 trillion a day. And he's like, holy shit. That's 12 zeros, $1 trillion. So it's obscene. It's obscene. This is where all our money goes, by the way. And I was like, the US national debt is 20 to 30 trillion, okay? These guys do, and that has increased from 1 to 2 or 3 because it's got really popular. Clearing is increasing all the time. So within a good week, these guys can clear the US national debt. It's completely crazy, okay? So there's no pressure, okay? 3 months, fix it, Robbie, okay? So there's no pressure. I'm working my weekends. We're all working very hard. So let me now explain one last concept, and then I'm going to explain how this works. So this is overlapping data cases, and I'm going to talk about, I've introduced TPS tracing, and now the last thing to introduce is garbage collection. So this is inside a Java JVM. Inside Java, you have something called garbage collection. Now, you can write PhDs on garbage collection, so I'm not going to do that. I'm going to tell you very quickly, stop the world garbage collection can pull back performance badly, okay? Specifically stop the world. So let's take an example. A plus B equals C, 10 milliseconds. A plus garbage collection, which takes 30 milliseconds, plus B equals C. The answer to get C now takes 40 milliseconds. So in the world of performance, stop the world garbage collection is a disaster, and you have to be very, very careful. So what we found was when we were doing the testing, we had an average of 99 milliseconds, and we needed 17, okay? The commits are in green. These are the commits. But then, so this is one data set. This is the TPS from the JSON tracing. Then we take in garbage collection and we overlap, okay? Because now we have two different data sets. One is garbage collection GC output and one is TPS tracing. And when you start doing this with your big data, you start seeing trends and problems that you would not have seen. Because these logs are massive. You cannot humanly read these logs, okay? They're too big. So what we saw was to stop the world, you see the peak? It's like it could take almost exactly the time that the trade was trying to take. So we were like, wow, because some trades were quick, 50 milliseconds, but some trades were taking 700-800 milliseconds. So they were causing big peaks. And the garbage collection is right beside it. So straight away we're, now that we see, one of our issues is garbage collection, okay? So let's look at an example. So this is before, and then I'm going to show you after. So before, a 10-minute test, the average is 99 milliseconds, okay? And then we're going to say you have the throughput, the max, the min, et cetera, et cetera. You hover over 500 milliseconds, 50 milliseconds. We need 17 milliseconds. So this is the baseline, okay? Now let's overlap the garbage collection. So when we overlap the garbage collection and we program the algorithm to detect 45% of the time is spent in para-new stop the world. A disaster. That should be like 6% at most. So now we zoom in and we can see the trade was 600 milliseconds and the garbage collection was 612, right beside each other. So the garbage collection is stopping the fast throughput that we need. So with this information, we go to the developers, and then they discover, we're cloning these objects wrong, and then we also pull out functional data, et cetera, et cetera. So I'm going to move forward now 3 months or 2 months, and now this is the solution. So we overlap the garbage collection again, and we can see it's down to 7%. This number is a number we like, okay? We go down here and we can see the trades at 14 milliseconds. This is a number we like as well. Garbage collection always happens and you will always get peaks, but sometimes you can't explain them. But the point is we got to say the KPI, 17 milliseconds. So we're happy. So this is a case where overlapping data sets can highlight a problem, okay? Now, there's a couple of slides just for reference if you download later on the mathematics. But I'm going to run through them quickly. The next one we talked about was millisecond analysis, okay? And the millisecond analysis was that the developers were happy with the Gantt, with the charts, but they wanted to see something different. So this is a Gantt chart. So a trade took 12 seconds here, and it goes left to right, going down. So these are all method.classes inside the calling of the real production environment, okay? So it goes left to right. So this is a situation in production, a trade's taking 10 seconds and the client is going crazy. They say, hey Murex, you need to fix this. This is our traders are giving out. Our developers look at this and they go, okay, it would be better if we could view this in a Gantt chart so we can see the information better. So you have your master class here, which takes 10 seconds. This then calls another class, which takes approximately 10 seconds as well. Okay? And then you get all these little subclasses called, and then your developers going down, they see we hit the caches, we do the preloads, and then all of a sudden we see, what's this? We're hitting the database. Database. Why are we hitting the database? We have loaded the caches, we should not be hitting the database. So the tool will not tell you the answer. It will highlight possible problems that your team can then look at, okay? It's not, Skynet. It's not, there's no artificial intelligence here. It won't jump back and say, hey, the problem is here. But it will help you to see where the problems are. So let's take another example. We're making a new module, an import task. The developer, again, has a small database, and he runs a small test. And you can see that the add point took 734 milliseconds, okay? 734. Oh, here's one here. And the store existing, so we're doing an import and we're flushing to the database, takes 73 milliseconds. That's sequentially. So now the question is, well, if the client get that in production, are they going to go sequential or parallel? And the answer is, clients will use this parallel. Have you tested a parallel? Oh, no, not at all, because I'm a developer and I don't test things like that. So can you please test it parallel? You test it parallel, and okay, so it's good and bad news. The 734, we tested 15 times in parallel, so the same report 15 times, okay? And 734 goes to 2000, so 3 times bad, not so bad. But we see something very obvious. Store existing, 73 to 1200, 17 times slower. And you go, oh, that's the database access. Question to the developer, is that sequential or in parallel? His answer is sequential. Should it be parallel? Yes, it should. You need to change your code. You know, so you find things like this that he maybe is not thinking about, or maybe he is so caught up in the functional, he does not think non-functional. And this is the problem we have in training our developers. You need to be thinking non-functional, you need to be thinking performance, because I don't want the client to test this 1 week before go live, and then there's a crisis, you know? So it's all about shift left. Give the information to the developers quickly, and they maybe be able to find these problems earlier. The last example. So where's my test? Let's say I'm testing binaries. I have 10 binaries to test. Each test takes maybe 1 hour. I go home, I come in the next day, and all I have is millions of lines in an axis. So we developed a way to hover these points, test 1, test 2, test 3. And the idea is that you can now see each section of the test much quicker. So this is a 3-hour test, or 2-hour test, okay? And we put on a Gantt chart here. And now we can see very clearly the export test 2, it started here, it finished there. And again, we see, okay, so the test took 1 hour and a half. It stopped the environment, took 10 minutes. The stop script took 5, sleep 120, start the CPU monitoring, then do the import test here. And that took X, because you want to compare X to the next binary. Did it fail? Click it. And then you get the JSON log. So you don't need to open up Notepad++ again. Your log is right there. Because how many times you open up Notepad++? It just, you open up the wrong log, you see the wrong data, it's a disaster. So you need to, again, another data set, any data set you want, and you program your big data tool to display it quickly, okay? So in conclusion, we had a problem. We had 4 problems. We needed to view millions and millions of lines quickly. The log drops we get can have trillions. So we can do 100 million lines in 10 seconds. This is our baseline. Now this did not come out of the box. So any big data tool, say for Splunk, I like Splunk, it could be Elasticsearch, it could be Datadog. You have to train it, you have to understand it, you have to try to get the best out of it. It won't just, it's not Microsoft Word, it won't just work. You know, it's a developing language as well, okay? It can be complex. The next one, we needed to be able to get data into Splunk quickly. So this goes down to the situation where I'm trying to roll out a system in the company. And if I give people 10 steps, they're not going to do it. I have to give 1 step. So live monitoring in 20 seconds, that should be 30, and log drop can be uploaded in 1 click. So the point is, any tester, any developer, any consultant, they can all just upload the data instantly, and then within 3 or 4 minutes, it indexes, and then they can see it, okay? Next problem, we needed to overlap different data sets. I talked about this in the $1 trillion problem. So this is like 1 data set is often not enough. You need multiple data sets. And when you overlap them, sometimes as a performance tester, it becomes obvious. Sometimes it doesn't, by the way, you know. But that's the way it goes. And then the final one, how do I show my colleagues quickly, okay, what I'm looking at? I have a problem. I want my developer who's in Beirut to look at this problem. I can't walk to his desk and make sure he understands. So I send him the Splunk hyperlink, and he opens it up, and he sees it straight away, okay? And then the final is a recap. So as I said, I'm not Facebook. This is a story that started with one user, and now I have maybe 70, but it's getting more popular within the company. My company maybe employ 2,000 people, okay? They're not all testers, by the way. We're a software development company. So this is the story of, I suppose it's my story. This could be Splunk, this could be Elasticsearch, this could be Datadog, okay? This could be any big data tool, okay? I chose Splunk because I was at a test conference and I downloaded it and it worked for me, for my problems. Maybe you can try the freeware, maybe you can try something else, okay? So that's me. I hope you enjoyed that. Thank you very much. Okay, so if anyone has any questions or not, that's okay. I hope it's an easy question.
Yeah, quick question. And have you changed log formats so Splunk can understand it and parse it quickly?
Yeah,
for example,
a good question.
Yeah, for example, as far as I know, Elastic works with JSON very quickly, but with normal log files, need to parse it, and it takes some time for it. So have you changed it?
Yeah. So the question is, did I need to go to the developers to say, hey guys, for Splunk we need to change the output? Okay. So this was a big question, and the answer is no, because one of my concerns was, you have to remember, I downloaded 4 years ago. Splunk costs money. I had to prove this tool was valuable. But I could not say, but we need to change lots. So I had to work very hard with what I had. As in, I had to, like doing regex or doing whatever, to take in the data to make it work. Because also remember, a lot of our clients were in production with the outputs already. So my objective was to change nothing. And I achieved that. But that wasn't easy, because obviously in the perfect world, everything would be JSON, it's all formatted or something. But we had log4j, we had CSV, we had raw file, we had horrible files. You know, so that's not easy. Now that I have developed, and I'm successful for say 4 years, now the developers are talking to me saying, hey, we're thinking about making a new log file. What format does Splunk want? Okay, and this is, but this has taken time. You know, because you have to prove yourself. Because you remember, people have to, they ask a question, will Splunk be here next year? Will I bother, you know?
And how long does it take to parse all these logs to the Splunk format?
Yeah,
so
no, it's good. If you have JSON, it's like that, it's no problem.
Yeah, and for you?
JSON is easy, but things like CSV is okay. Log4j can be difficult. Because you need regex and stuff, so you have to get used to regex and stuff. I mean, we had very complicated logs. I mean, crazy complicated. But we got there, you know.
Yeah, and how long does it take for you?
To parse the log, honestly, maybe... So number one, you need to understand the log. So a simple log, a CSV, where it's just like column, 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 that's easy. Okay, so maybe half a day, you know, maybe a few hours, if it's simple. If it's a log4j with crazy format, it takes maybe 1 or 2 days, and maybe you have to ask questions to the Splunk experts. Say, hey guys, I have this problem. And Splunk is very good for the online board. So you ask a question, and someone will come back with an answer. So you are not alone in the world, you know? So to answer your question, a simple log, a few hours, a very complicated log, maybe 1 or 2 days, depending on how quick the answers come back. Is that okay? Yeah. Sure. Okay. Can I use taboo with your approach? I'm trying to remember what that is. I know the name of this. I should know this, right? Hey.
Hi, Robert. Is this working?
Yeah, sure.
Okay. So I actually did this. I said anonymous because I forgot to put my name.
Don't
anyway,
worry. It's okay.
So Tableau is a BI tool, and
you know why? Their headquarters is based in Dublin.
Okay, I didn't know that.
Sorry, because I was like, I know that name.
Yeah. So I was wondering if you could use it with your approach, because I really like in Tableau how it's drag and drop.
Okay.
So you can say, oh, maybe I want to look at CPU, drag it onto the graph, and it's just,
Sure.
it's so easy to kind of experiment with the data when you don't know what you're looking for.
Yeah.
Is that something that you think would work? And my second,
Yeah.
okay, maybe you can answer first.
No, I'll take the second. Give me the second, please.
Oh, my second question was, do you actually store the raw data for all of this? Because if so, how? How do you store millions of data?
So I'll answer two questions. So the first question is, the software Tableau is a BI software. Headquarters is actually in the office block I'm in Dublin.
Oh.
So just because I was like, I know this name. I don't know enough about it to fully answer this question, I'll be honest, okay? Splunk is a full stack. So Splunk goes from A to Z, okay? Where other softwares, I'm not sure. So we take in the raw files, we index it, and we display it. And we put on mathematical algorithms, and we display it. I'm unsure in Tableau if it's a full stack or not, as in does it take in the raw data as well, or do you rely on Elasticsearch, or does Tableau read like...
No, it's full stack,
yeah. Okay. My feeling would be they're competitors, and they wouldn't be, you know what I mean? It'd be like Datadog or Elk, because sometimes people often ask me, can I read from Elasticsearch? And the answer is, I think I can, but it's a Python script and does this, and there's no natural way to do it. So I think these companies, like say Datadog or Tableau, they want to get their client base. And it depends on, you know what, this time next year, maybe there's an API, but at the moment, I don't believe there is. Okay?
There is. That's why I was asking. I thought it would be interesting.
Yeah.
They're definitely competitors, but you were saying that it could be Elasticsearch or the Elk stack at least, or Datadog. So I was thinking maybe Tableau would be another thing to explore.
Yeah. Because Tableau is a pure BI as well. It's a proper BI.
Yeah.
And the second question is, how do I store the data? So, number one, when people FTP their logs to my machine, when Splunk ingests them, we delete as we ingest, okay? So the raw file gets deleted so that the partition on my machine doesn't get full. And every night we purge it as well for extra files. So you might upload 100 megabytes. We only take in maybe 20 or 30 because we only train Splunk to take in 20 or 30. Because you don't want to take in bad files, because you can, there's no point. When you ingest inside Splunk, you set a retention policy. So normally we do 3 months to 6 months. So after 3 months, the data just drops off. And that's what we do. So the size of my partition, I use a solid state disk of 5 terabytes, and I use maybe half that. And I'm always monitoring this. So I use 2.5 terabytes data coming in. And if I get bigger, I'm going to have to expand onto more machines, but I'm not there yet. So it's definitely something I keep an eye on. Okay? Sure, thanks for the question. Any other questions? Okay, we'll call it a day. Thanks for listening, everybody. I hope you enjoyed that.